Since problem number 1 here has us dividing by a binomial, we're going to need to use long division. So let's set up the division bar. The x squared plus 6x minus 11 goes underneath, and the x plus 8 goes to the left. We want to start by dividing first term, so x into x squared. Quotient rule tells us to keep the base and subtract the exponents. That means x will be the beginning of our answer. And we want to then multiply that back by the entire divisor. So let's drop down that x and take it times x plus 8 to get x squared plus 8x. And where that really needs to go is on the next line down. Now we know what's going to be subtracted. X squared minus x squared cancels out. 6 minus 8 makes negative 2x. And we'll drop down the minus 11. And then we'll start the whole process again. By the way, over on the side here, I'm just trying to kind of show what we're thinking through. Don't feel like you have to write all that down. Where it really needs to show up is here, the results. So, optional work over on the side. Now that we're ready to repeat the process, we want to divide the x into the negative 2x. Again, just using the first term in each to help us get going. Those x's cancel, and that makes a minus 2. So that's the next part of our answer. And we're going to drop that down and multiply it by the entire divisor, x plus 8. And that result really needs to go right here. So negative 2 times x, and then negative 2 times 8. Helps us know what to subtract. So the double negative makes that a positive, which is going to cancel with the negative up above it. And then we need to be careful with our signs here. Negative 11 minus negative 16, or in other words, negative 11 plus 16 makes 5. So it's a positive 5. That means we want to add on 5 over our divisor, x plus 8. So all of this up top will be our final answer from the long division. In number 2, we just need to use our basic rules, so we're going to divide the coefficients to get 6 and subtract the exponents to get 6p to the 6th. Number 3, there is a trinomial on top, but there's only a monomial on the bottom, so this is an example where term by term is the way to go. We just want to divide every top term by 5m. If you find that it's helpful to write that out as an extra step, you always can. Like showing each of these as being divided. But you don't have to do that as a separate step. If you're able to go straight to your final answer, that's okay too. So divide the coefficients and subtract the exponents to get 5m squared minus 3m plus, this one is going to completely divide out, so it does cancel, but when we cancel by dividing, it leaves behind a 1, since 5 divided by 5 makes 1, so we will still have a third term in our answer, 5m squared minus 3m plus 1. Take a second to pause the video and see if you could tell what type of division we would use for each one of these. You don't need to divide it, just want to tell whether it would be long division or term by term division. So term by term division is when you're dividing by just one single term. Like in number 1 here, that would be term by term. And in number 4, we're only dividing by a monomial, so that would be term by term. On the other hand, when you're dividing by a binomial or bigger, we need long division. So number 2 is dividing by a binomial, that makes that one long division. And number 3 also is dividing by a binomial. So term by term, long division, term by term. Try pausing the video again to see what answers you come up with for these 4 problems. Should be a mixture of our basic rules, term by term, and long division. So our basic rules give us 7w to the 6th for number 1. Number 2 is dividing by a binomial, so we need long division. M plus 6 is being divided into 2m squared plus 6m minus 36. We'll start with the first terms. 2m squared divided by m. And we'll multiply that back. I'm going to drop it down and multiply it by the whole divisor. And put that result on my next line down. So we know what to subtract. 6 minus 12 makes negative 6. Bring down the minus 36. And do a bit more dividing. Negative 6m divided by m. The m's cancel, so that's just a negative 6. So I'm going to drop that down and again multiply by the whole divisor like we did here. And put that result on the next line down. Looks like the double negatives are going to make both of those cancel. So we have no remainder. And the answer is just 2m minus 6. Number 3 is an example where we need term by term division. Since we're only dividing by a single term, there are not any x's along with that 3. So really we just need to make sure to divide all these coefficients by 3. The x parts will stay the same. So 24 divided by 3, 8x cubed, plus 5x squared, plus x minus 1. Number 4 is also dividing by a binomial, so another example of long division. We want the 3y plus 11 out front, the 12y squared plus 65y plus 77 underneath. We'll start by dividing the first terms. That gives us 4y as the beginning of our answer. Going to drop that down and multiply it back by the entire divisor. And put that result on the next line down. Do our subtracting. First term cancels like we expect. 65 minus 44 is 21y. Bring down the 77. 3y goes into 21y. 7 times. It's a positive 7, so we want a plus in front of it. And then we'll bring that down, multiply by the entire divisor to get 21y plus 77. So it looks like no remainder. The answer is just 4y plus 7. A lot of times the long division takes a little extra practice. And term by term has a few twists and turns in it that we want to make sure we're ready for. So good time to pause the video again. Try a little bit more practice on this last page. Should be a mixture of term by term and long division problems. So number 5 is term by term, and it starts off pretty normal. There is a little something strange when we get to this last part where we have a negative 15 over a 5n squared. Because the 15 and the 5 will reduce, I can divide those both by 5, which leaves a 3 on the top. And the only n's are on the bottom, so we end up with 3 over n squared. Number 6 is long division. There are 4 terms in that top polynomial though, so it makes for a little bit longer problem. This one turns out to have no remainder. Number 7 is also term by term. There's a little something weird in the middle here where the x's cancel like usual. We can use our quotient rule there to get x to the first. But the 15 and the 6 don't divide exactly. You can reduce them, just like a fraction where you have 15 over 6 since they're both divisible by 3. And that leaves us with the 5 on top and the 2 on the bottom. So the coefficient still happens to be a fraction along with that x. The 6x over 6x divides out, cancels to leave a plus 1. And for number 8, again, we have long division. Here are the steps we're thinking through. Turns out this one has a remainder.